Hello, welcome today to the law of sines. This is another really, really nice formula. It's all about proportions, and when you solve a proportion, you use cross product. So starting with exercise 1, they want us to go back to what we did yesterday, write 3 different equations that express the area of this triangle. So I can find the area of this triangle from angle A, and if I find it from angle A, then I would have the sine, the area would equal, and then I would be using the 1/2 BC side B times side C times the sine of angle A. So there would be the area if I was going from angle A. Now, if I was going from angle B, which would be here, I would have the area is equal to 1/2, and then I would be using side C and side A, and then the sine of angle B. And if I wanted to go from angle C, I would have the area is equal to, now I have side A times side B and the sine of angle C. So it really just matters where you're starting from, which angle you were given. Now, part B says write an extended equality that relates to 3 expressions. Well, if you're finding the area of the same triangle from the 3 different angles, I'm just going to type this now. What this is saying is that 1/2 side B times side C times the sine of angle A, oops, that's got to be capital, has to be the same as 1/2 side C times side A times the sine of angle B. And again, since it's the same triangle, it would equal, 1/2 side A times side C times the sine of angle C. And that should have been a B. There we go. So now, finding the area from the 3 different angles, they're all equal to each other. Now, if we take C and it says divide each side, or each piece rather, because if you're equal and you do the same thing to everybody, if we divide all of these by the same 1/2 ABC, and let's do that. Let's divide each of these by 1/2 A times B times C, because with equations, if you do to one and you do to them all, you stay equal. So let me just do this, and let's clone this. Now they're all equal because I did the same thing. But here's the thing. I can reduce. The 1/2 will reduce, the B's will reduce, and the C will reduce. Look at what we're left with, sine of A over A. And that's going to equal this, the sine of B over B when I reduce. And that's going to now equal the sine, that's a bad, of C over side C. There's my law of sines. We just figured it out from the area. The law of sines is all about a proportion. The sine of the angle to the side opposite. Now, really, really important is, notice angles are capital and sides are lowercase. So if this is angle A, this is side A. And if they want me to determine side AB, well, side AB is actually side C because it is opposite angle C. So if I wanted to find AB, so let's just do this together. If we want to find AB, that means we have to find side C. And in finding side C, we need to have the sine of 80 over 16, the opposite side, and that ratio is going to equal the sine of 68 over that unknown side of C. So let's just clean this up so we can read our proportion a little bit better. I'm going to try to make this as neat as I can and go as quickly without taking too much time because of writing on this with the mouse. But people in the class have told me that this is what they prefer because they can see up close everything I'm doing. So cross product, I get C times the sine of 80 equals 60 times the sine of 68. So the next line now, when I use cross product, I have C times the sine of 80, whoa, is equal to 16 times the sine of 68. Now, if I'm going to find C, I have to divide both sides by the sine of 80. And that looks like this using division. And here they cancel. And that now is going to leave me with, when I divide on my calculator, again, make sure you're in degree mode. If you hit 6, and I'll do it this one, I'm not going to do all of them just because some of these videos take so long when I go super slow. And then people say, oh, it takes too long to do the work. 16 times the sine of 68. Make sure you hit enter, get an answer, and then divide that by the sine of 80 and hit enter. So your C is now equal to 15.06379456. And then they say round it to the nearest tenth. So now C is roughly, remember when we're rounding, we are not exact, so therefore we would use this, and the nearest tenth would be 15.1. Okay, so there was finding side AB. Now what I have to do, let me just move this over so we can read it a little bit better. There we go. Now I need to find AC, which means find lowercase b, because here's 32, and opposite 32 would be lowercase b, and that was my side AC. So again, if I write in what's going on, I have the sine of 80, and that's going to be over 16 again, because the original ratio they give you is going to be the one you're going to always end up using, and that's now going to equal to the sine of 32 over this unknown side b. Again, I'm solving for b. So when I cross multiply and I get 80 times the sine of b, that is going to equal 16 times the sine of 32. So this is going to give me b times the sine of 80 is going to equal 16 times the sine of 32. To get b by itself, I must divide by the sine of 80 on both sides. So I'm dividing by the sine of 80 here, and I'm dividing by the sine of 80 here. These are going to again cancel, and when I type this into my calculator and I have b equals 16 sine of 32, I hit enter, and then I divide by the sine of 80, I get 8.609505969, and again they said round this to the nearest tenth, so b is approximately 8.6. And there you have it. So the law of sines is actually quite a fun little formula to use. I like it a lot. Let's take a look at the next page, where now we have to find to the exact amount the length of DF. Now, when they say exact, they're telling you you have to go back to your special triangles and look at 45 and 30. So, because we're going to take the sine of 45 when we're using angle E, and we're going to take the sine of 30 when we're using angle F. So if you go back in time to that chart, and we go back to our special right triangles that we had to know, and just quickly, if I have a 30, well, that's a bad 3, 30, 60, 90 right triangle, opposite of 30, we have 1, hypotenuse 2, rad 3. And when we have our 45, 90 right triangle, this is my isosceles. So from here, the one thing I know for certain is that the sine of 30 has the exact value of 1/2, and that was from that chart back in chapter 9, lesson 3 was when we started, and then we used it all through chapters 9, 10, 11, 12, and now we're in chapter 14, and this is the sine, and in case you're wondering, we do skip chapter 13 this year. That was never in our curriculum. It's way, way, way advanced. You'll learn all of that if you go to advanced algebra or pre-calculus in college. And the sine of 45 we always ended up with, after we rationalized, was rad 2 over 2. So these are exact, and that is what they mean. When they say exact, you better remember your special triangles. I told you from the beginning, they will never go away for the rest of this school year, and if you go beyond, these triangles are always going to be a very important part of the work. So now they want me to find the length of DF, and here is DF, it's opposite E. So DF is opposite side angle E, so it's side E, and they want that in exact simplest form. So I have a couple of ways I can go, but no matter what, I'm opposite 45. So this would be the sine of E, sine of angle E is to side E as, and the only other ratio they gave me was angle F and then side F. So this would be the sine of angle F, and that is opposite side F. So here's my law of sines using the letters they gave me in the problem. And so now this would be the sine of angle E. Well, the sine of angle E is the sine of 45 degrees. The sine of 45 degrees is rad 2 over 2. So this would now be, I'm going to try to use this just so that it's very easy to read. So now here I have a fraction, and in the top I have a radical. Where is the, here it is. I have radical 2 over 2. Okay, that worked good. And this is going to be over side E, which I don't know what side E is. So and this is going to equal the sine of F and F, the sine of F is the sine of 30, and the sine of 30, I don't know why this isn't starting. Oh, yeah. Okay. This is the fraction 1/2 over side opposite, which is 20. See, this is my side F, which is 20. So if I use cross product, I am going to have 20 times rad 2 over 2 is going to equal 1/2 E. So this is going to give me 1/2 of E is going to equal 20 times rad 2 over 2. Now, 2 goes into 20 10 times. So if I have 1/2 of E is equal to 10 rad 2, and I want to get rid of 1/2 on both sides, remember I have to multiply both sides by 2 to cancel the fraction. Opposite of division is multiplication. And then that gives me side E is equal to 20 rad 2. There you go. Now, if we take this next one, they give me that angle H is 25. That means this 12 over here is actually little h. And then they tell me that this is 26, and this is opposite angle L. I mean, angle I. No, that's an I. So this is side I is 26. So if I were to write the law signs using these, I would have the sine of H is to side H as the sine of angle I is to I. And then that gives me this ratio. So I want to fill this guy in. I have the sine of 25 over 12. And you know, let's just see if I can get this to work. If I can, that'll make life easier. So the top is the sine of 25 over 12. This is going to equal the sine of angle I over 26. So when I use cross product now, I am going to find that I get, and let me do this over here now, 26 times the sine of 25 degrees is going, well, that didn't work. Let's go back. I guess you can't, I gotta be really careful with the symbols I use. Let's try that again. When I use cross product on this, I get 26 times the sine of 25 is equal to the sine of I. Oops. I'm not even going to try to hit the back, times 12. And then if I want to solve for the sine of I, the one thing I'm going to have to do is divide both sides by 12. And what that does is it's going to cancel these 12s. But this I have to type into my calculator and just make sure you're hitting enter. So this way you don't type it in wrong. So we have 26 sine of 25. Hit enter for the numerator. Then divide by 12. Now keep this on your calculator because now that's the sine of angle I. And if that's the sine of angle I, which I'm actually going to type in right now, so this gave me 0.91567290004 is now equal to the sine of I. Then if I want to solve this, I need the arc sine. I need that -1 from the calculator, the arc sine of this number and that's going to equal angle I. So when I type that in, I end up getting roughly 66.3 degrees. So 66.3 is roughly the measure of, oops, I hit the wrong thing, is roughly the measure of angle I. And here we go. So hopefully using the symbols on the calculator helps you guys to see everything a little bit more neatly. That's my goal. But the problem is, when I look at this picture, I say to myself, wait, this is an obtuse angle. This is an acute angle. This is an obtuse angle. So this 66.3 degrees must be a reference angle, and it's sine, so it's positive in quadrant 2. That means I need 180 minus 66.3 to find that angle I is equal to 180 degrees minus my 66.3 degree reference angle, and that now tells me that angle I is 113.7 degrees. So this kind of ties back into the work that we've already done. And so I wasn't lying when I said things are not going to go away. We have to remember everything. So let's take a look at, or that's why you also have all your notebook and all your notes. Hopefully you refer back to things you don't know. Okay, so now let's take a look at this big thing. They gave us two angles, but I have a triangle here and a triangle here. Now, one of the things I know from geometry is that all the angles of a triangle make 180. So if this is 20 and this is 115, 20 and 115 add up to 135. 180 minus 135 tells me that this angle up here is 45 degrees. I also know that these two angles together are forming a line, and a line or a straight angle is 180 degrees. So 180 minus 115 tells me that this angle down here is 65 degrees. And then I have 90 degrees and 65 degrees, which is 155 degrees. And if I subtract that, this angle up here is 25 degrees. Now, do I need all these angles? I don't know. But one of the things I always do is label as much as I can. You guys should be used to that by now. I don't leave anything to anyone's imagination. Now, they want me to eventually get to side AB. That's what they want. This is the goal of this problem, determine the length of the side of AB. Well, I can't get to this side yet. I don't have any lengths of any part of this right triangle. But what I do have is the sine of 45 is opposite 18. So this is my little side A. And I can find the hypotenuse of this triangle by using this. I'm going to just call this side X. So if I were to write this out right now, this is going to give me the sine of 20 degrees. You know what? I should have used the fraction. So let me just finish this up with typing. The sine of 20 is to side X as the sine of 45 degrees the sine of 45 is to 18. Okay, so here are all here's my original ratio. Now when I cross product, I get x times the sine of 45. They didn't tell me exact. They told me to round in this problem, so I don't need to dread 2 over 2. Is 18 times the sine of 20. And if I'm solving for x, I'm dividing both sides by the sine of 45. And these are going to cancel. And now I would use the calculator to find out what x equals. And let's do that right now. 18 sine of 20. 18 sine of 20 divided by the sine of 45 gives me this long number, which I'm going to keep on the calculator. I am not going to eliminate this from the calculator, so I'm actually going to move this over here just so we can keep it up as we need it. This number was 8.706411455. Okay, so that's staying. This now is the length of this side here. And that's opposite my 90. Now I need this side here, which is opposite my 65. Let's just call that y. Now let's see if I can actually type this whole thing from the beginning the right way and then make it nice and easy and quick. So this one now would be the sine of 65 degrees is to this unknown side that I just decided to call y. And we now have sine of 90 is going to be to this answer that's on my calculator. So you know what I'm going to do? I'm actually just going to write what's on the calculator, answer. When you use cross product, you are going to have y times the sine of 90 is this long answer times the sine of 65. So now this would be y is going to equal, and you are going to again have this answer times the sine of 90 sine of 65 rather. I don't know if it's going to let me fix that, so let me do this. This is 65. There we go. Sine is 65, and I'm going to be dividing, let's see if I can fix that now, by the sine of 90. Now, on my calculator, since it's still there, left it on, I'm going to now just simply have multiply by the sine of 65. Now, I don't have to worry about retyping it, nothing, hit enter. And now I'm dividing this by the sine of 90, which you'll notice doesn't change the work at all, because going very back to chapter 9 again, The sine of 90 on the unit circle is 1. Anything divided by 1 is itself. So if you always remember that the sine of 90 is 1, you don't even have to write it. For those of us that won't remember that, write it out and just always be confident that your work is correct. So now we find that the y is 7.890688,499. And that means that y, if I round this to the nearest tenth like they asked me to, is about 7.9. So I like this unit. I think it's pretty nice because it's all formulas. I want you to do for homework 1 through 7. 8 so is a little bit more work. If you want to do 8, feel free, but definitely do 1 through 7. 7 is exactly like this problem 5 that we just did. So always refer back to the video. Good luck.